Hello, my name is Nikki, and I currently work at a data X lab at Berkeley, and I'll be going through this code for the first NLP module section with you. So first, how this code is divided is first we're going to explore the data and gather some information about it, and then we'll perform cleaning, tokenization, lemmatization, stemming, and removing stop words from it, and then we're going to prepare the data for our classification. So the data that we're working with is this data set, and what it consists of is 25,000 IMDb movie reviews, and then we also have unlabeled test set, which we're going to use later for when we use training models. And the sentiment of the review are binary, so if you have less than 5 results, you'll get a score of 0, and you have a rating greater than or equal to 7, you have a sentiment score of 1. And so there's two files, labeled train data and test data. We're only going to be working with the labeled train data right now. And the data columns have ID, sentiment, and review. So first we're going to explore the data, and we're first going to read the data in. Since we're working with TSV files, we're going to need to use a delimiter, and that's how you read TSV files. If it's a CSV file, you would just input the file and you wouldn't need anything else. And looking at the dataset statistics, first we can look at the train dot shape, so we know there's 25,000 rows and 3 columns, and train dot head helps you just get a glimpse of the first few columns of the dataset, so you can see what it looks like, and you can see there's 3 columns and whatnot. And then train dot info helps you look at what type of information is within each column, and you can also see that they're all non-null objects, which means there's no NANs, therefore you don't have to remove any of the null objects, which you would otherwise need to. And first, let's look at how many movie views are positive and how many are negative in label train data.tsv, and do we have a balance between the classes. So it's important to look at how many there are and if there is a balance, because if there isn't a balance, let's say one only has 100, there's only 100 of the data sets labeled 1, and then still 12,500 labeled 0. When you're classifying, it will skew more towards 0 than 1, so there won't be as an the accuracy of the declassification won't be as high. And how you resolve that if it is unbalanced is if one had 100 data points, instead of using all 12,500 data points that are classified 0, you'd only take a sample of 100. But in this case, it's balanced, so we don't have to do any of that once we move on. And another thing to look at is just the average length of all the reviews. And part 2 is nltk, so we'll look at cleaning, tokenization, stemming, lemmatization, and removing stop words. So first, you just have to download a lot of things that I talked about in lecture for us to use. And now we are going to get started with cleaning the review. So in order to remove HTML tags, one thing to use is Beautiful Soup, and it's a Python library for pulling data out of HTML and XML files. So what this line does is first it pulls out all the data, right? And then what .txt does is it puts it back into a text form. And the second thing we are going to do is, so essentially removed all the HTML tags. And the second thing we're going to do is we're going to import the tokenizer and count the number of sentences in review 3. And so first you import it, right? And then you print the length of the sent tokenized review and then sent tokenized review 3. And we can see that it doesn't really split all sentences. And then check if, so now we are going to try to find another option. Check if it does a better job if we add a space after every period, because for some reason the sent tokenized didn't really split all the sentences. And you can see here that it did a better job. So depending on the data that you're working with, sometimes it's split based on different things, so it's useful to print and see if it actually splits it properly, and if it didn't, then to incorporate another way to split it properly. And step 3 is to remove all punctuation and special characters from the third review, right? And this is where we're going to use regular expressions, and so what this does is it substitutes all of the all values that are not either lowercase words or uppercase words with just a blank space. So essentially removes all the special characters. And so all we're left with is text. And since we can see that there are some capital letters, some lowercase letters, it's important to lower all the letters by using the 3-dot lower and split the string so every word is one element in a list where we use dot split. And after we split it is when we can stem, since if you pass in a sentence to a stemmer, it spits out the original sentence. And in this case, we're using Porter.stemmer. And so first we initialize a Porter.stemmer object, right? And then for each word in the review 3 words, so we iterate through each word, we rejoin it after we stem it. So now we have all the words back rejoined together. And as you can see, since we use the stemmers, not all the words are actual words of the language, like the, right? And praise is missing an E and things like that. So next we're going to move on to, but if we use the llamatizer, these would actually all be proper words. But the benefit of using a stemmer is that it is faster. And the part of speech tagging, moving on to this, we want to part of speech tag the thermal review, and we will, which is also called grammatical tagging, and so we're going to import the POS tag from nltk.tag. And so as you can see, we are able to tag it to a PRP, right? So B is a verb, VB stands for verb, and whatnot. And so, for example, NN stands for singular nouns and adjectives, and you can see what they stand for over here as well. And so then we can count how many, let's say, number of nouns and the number of adjectives, which is useful knowledge moving on. And so here we use a llamatizer, so it's even more sophisticated operation than stemming. So as I said, it doesn't create non-existent words. And lammatization, as you can see here, you can specifically get, so this function, what it does, the get word net pause, is it returns an actual word. So if the tag is a J, right, it returns the word, not the adjective, which is something more readable. So if it starts with V, it returns verb, and N starts with noun, because since it's a bit hard to understand what MD, for example, stands for, or VBN stands for. So looking at this function here, this is where the lemmatization happens and what we've been doing comes together, because looking at the lemmatizer, the POS argument, it automatically is a noun. So since we've gone through the process of actually categorizing each word properly, it's going to increase the accuracy of the lemmatizer. So what we do is we iterate through each token tag, and pair 0 is just the word, and so we pass that in. And for the POS argument, we we pass it into this function get word net position, and it'll return either adjective, verb, noun, or adverb. And then afterwards, we can do is append everything and join it, and here we have the properly lemmatized text. And so as you can see, these words are all actual English words, so you don't have THI anymore, you have this, the word this. And so moving on, what we're going to do is we're going to remove stop words. And so these are common words that don't carry much information. And so for example, if you use the nltk.corpus stop words, this is all the stop words that they have. And so here what we're doing is we're going to print the first review without stop words, and then we can, since we're going through each letter and removing it and only keeping it if it's not in stop words. And here are all the lists of the stop words that we removed from the sentence, and there's a number of stop words that we did remove. And the last part of this code is we're going to be preparing the data set for classification. So first what we need to do is review the cleaning function. So we're going to create a function called review cleaner that reads the review and removes the HTML tags, extracts the Emoticons removes non-letters, converts all words to lowercase and tokenizes them. So essentially what we've been doing, so bs.beautiful-soup, right, .text, and then we're going to use regex to find all emoticons and remove punctuation, so anything left over that's not letters, and the tokenize into words, so lowercase. So this is a lot of stuff that we've just been doing, so removing stop words, but we're putting it into a function called review cleaner. And so what we can do is call review cleaner on, let's say, this part of the data, and this is what it spits out. And we're going to also create original, Porter, stamped, and lemmatized data sets. So we're going to create 3 lists. First, called review clean original, which contains all reviews from the trained data frame that been cleaned by the function review cleaner defined above. And we'll have review clean ps, which applies the Porter stemmer to reviews in review clean original. And we're going to have the review clean WNL, which contains words that have been lemmatized using nltk's wordnet llamatizer on the words of the list. So first, we're going to look at this, and since it take more 10 minutes, I've already ran it. And what this essentially does is it tells you how many reviews it's completed, and what it's doing is it's iterating through the number of reviews, right? And it's just calling review underscore cleaner first on it, and calling and adding it to review underscore clean original. So this just review underscore clean original just has all the data that is has gone through review underscore cleaner, which we wrote here. So after that's done, what we're going to do is call review cleaner. So this is just an example of what review clean underscore original 3 would look like after it's been cleaned. And so here what we're going to do is create the Porter stemmer, and we're going to iterate through and call Porter stemmer on it. So as you can see, we're going to first we're going to go through all of the individual words that have been cleaned, and we're going to stem them, and then we're going to append them all together. And so this is an example of what it looks like after it's gone through the stemmer. As you can see, since the stemmer, there's words that aren't, like praise once again, and assume that aren't exactly words. And so what we're going to do is go through a word llamatizer this time, and we're going to run each word through the llamatizer. So this is similar to what we did with pause underscore tag, right? And we're going to call these functions that we created before, and then call wnl.llammatize on it, and then we're going to append them all together. So after that's done, for example of the underscore clean underscore wnl wl3 is this after it's been lemmatized. So you can see word praise has the word praise in it. And that is all for this section of Module 1 code, and we will be continuing this code in the next